So we define this operation of taking the principal square root to sort of undo the act of squaring, or at least as best as we could with, given restrictions on the sign. Sometimes we ended up getting an absolute value. Let's try to do something similar for, say, cubes, or maybe fourth powers or fifth powers. What would we get? So what we can do is we can define the principal nth root of a to be b if b to the n is equal to a. But we do have to be a little careful when it comes to signs again, positives and negatives. So what do I mean by that? Well, if a is positive, if a is greater than or is strictly greater than 0, then what we're going to do is we're going to also require b to be bigger than 0, just like we did before. If a is negative and n is even, well, we're going to have a problem here, because if I take a negative number to an even power, I'm always going to get a positive number. And if I take a positive number to an even power, I'm also going to get a positive number. So I'm never going to be able to get to a if a is negative. So we're basically going to get into a situation where there's no solution. Does not exist. No solution in the real numbers, which is where we're looking right now. If a is less than 0 and n is odd, though, well, that's fine. Because if I take a negative to an odd power, we're going to get a negative number. So that's going to be wonderful. It's going to work out. We don't have any restriction that b is greater than 0. All we need is some number so that b to the n equals a. It turns out that such b is going to be unique in the real numbers, but we can see that later. What if a is equal to 0? Well, this is the easiest. Then the nth root of a is equal to 0. To look at some examples, let's start off by taking the fourth root of 16. Well, I want some number so that b to the fourth is 16. I could think about that for a while, or I could even rewrite 16 as 2 times 2 times 2 times 2. And I can see right off the bat that I'm going to get 2. Why 2 and why negative 2? Why not negative 2? Because I could have taken negative 2 to the fourth? Well, because we're going to require the number to be positive. Okay. What else? Let's do another example. Let's try to take the fourth root of negative 16. Does not exist. We can't do it, as we saw here. What if we wanted the cube root of 8? Well, it might help me to write it like that. I see that I immediately get 2. No restriction on the odds, so I don't have to worry. If I want the cube root of negative 8, well, negative 8 is just negative 2 cubed. So that's fine as well. So those are some examples that we get. Let's do another one. Let's do an easy one. Cube root of 0, I'm looking for some number that when I multiply it times itself and then multiply it times itself again, I get to 0. Well, I could also just use this rule up here, which says we always get 0. But either way, I'm going to get 0, because actually 0 times 0 times 0 is in fact 0. So straight from the whole idea of how we're constructing these roots, I get 0 as well. So those are some examples with finding the principal nth roots. And now we have to maybe think a little bit about whether we can find some rules that will help us simplify in these situations.